So for this we need to calculate the penalty cost, which is the difference between two costs, maximum and minimum. 13 minus 0, 13. Here 7, difference between two minimum costs, 13 minus 0, 15 minus 0, and here again, sorry, 0, this one, 15 minus 0, here 15 minus 13, 2, 17 minus 2, so 17 minus 16, 1, 19 minus 17, 2, 17 minus 16, 1, 0 minus 0, 0. Out of the penalty cost, select the highest penalty cost and allocate to that row or something. Highest penalty cost is 15 is there, so allocate to any of the cells. So allocated, I allocated 100, then that column got cancelled. Again calculate the penalty cost. So again now penalty cost is difference between through last minimums, that 16 minus 13 3, and 17 minus 16 1, and 17 minus 15 2, no 16, this one 16 minus 15 1. Okay, so then again look at the wherever the highest penalty cost highest is now 3, allocate in that corresponding row. So where you need to allocate, anywhere, any location. So that 3 means here where least you need, wherever you need to least cost only you need to allocate. It's not like anywhere in that row you need to allocate for least cost. So 13 was least cost, I allocated 100, so that row, column got cancelled. Next, after allocation of that 100, you are remained with, out of 250 only 100 was remaining. Then again calculate the penalty cost. Now it is 17 minus 16 1, here again it is 16, 19 minus 16 3, again here 16 minus 17 is 1. So again highest penalty cost is 3, allocate 100 from that to least cost. So here allocation is again allocated to here 6, S2D4. Next, after allocating S2D4, that row and column both will get cancelled. Then what are the remaining columns? D2 and D3 are remaining. Those demands has to be assigned. For that again you need to calculate the least cost, D2 and D3, D2 and D3, 3 0 0. So 3 is the highest cost, and even in row wise if you calculate 1 2, so 3 in 3 allocate first. So 250 250, whichever is minimum, allocate that one. So minimum was 160, 16, 150 get allocated. So next another remaining values is that row and column will got cancelled. Here you need to allocate 250, so only one availability is this. So now number of allocations equal to 5. Five is right, yeah. Number of allocations is 5. It's very, I mean, less, it is less than the optimal allocations. Optimal allocations is m plus n minus 1. So less than optimum allocations. So odd Odd epsilon, some random number, allocate random number epsilon very small value to any two cells. Now number of allocations equal to the optimum allocations m plus n minus 1. So you can start with it is a completion of initial basic feasible solution. Next step is calculating optimal solution. To get optimal solution, you need to use not Vogel's, Modi's method. Here we need to calculate opportunity cost. So after getting initial solution, calculate the opportunity cost in the Modi's method. So first, suppose for example, initial solution obtained by any method, take northwest corner rule or any method, least cost or as any method. So for that method, we have to calculate opportunity cost. So allocations are 100, 50, 100, 100, 150, 100, 100. These are the allocations. 7 allocations. So for this we need to calculate opportunity cost. So for getting opportunity cost, this is U and this one as V. Take one value as V1 or something equal to 0, 0. Then if V11 is 0 or V1 is 0, correspondingly U1 equal to how much? 13, because the cost here whatever is there available has to be equal to the sum of the u1 plus v1. Based on that condition, ui plus vj equal to cij. C is the cost. For example, here u1 plus v1 is equal to 13. Here v1 is 0, so u1 equal to 13. So similarly, we allocated 13 to this row to 15 here also. So this value will get 3, and this is allocated. You check these corresponding allocations 3. There is allocation of 100 here with 17 cost. So here you will get 14. 14 allocation here you will get 3. 3 allocation correspondingly here it is 16, right? So 13. 13 correspondingly you will get 2. Similarly 13 is allocated here, the value here is minus 13. right, all allocations are over, and try to allocate the cost for non-empty cells. So for example, d s1 d3 equal to 19 minus, for s1 d3 you need to calculate allocated value. s1 d3 equal to 19 is already allocated cost minus 13 plus 3 is equal to 3 positive value. Similarly, s1 d4 is equal to 17 minus 13 plus 2 is equal to 2. Similarly, s2 d1 17 minus 13 plus 3 equal to 1. So for the like similar in the same way we need to calculate for all values. Wherever it is, it has to get all positive. If it is coming negative, for that cell we need to do modification. So then after completion of that, suppose for example s2 d1 we have done. What else? s2 d2 is equal to 19 minus 13 plus 3. 13 plus 0, it is 4, it is 3. So similarly calculate for s2 d5. s2 d5 is 0 minus 13 minus 13 is equal to 0. Calculate s3 d5. 0 minus 14 minus 13 is equal to minus 1. Here we are getting negative value. So for to again that reallocate by forming a one loop starting the cell where you got different sign. That allocation has to pass through all the allocated cells. Start from this point, and so this has to go, this is the one, and another one again come back. So starting point is positive and assign negative, positive, negative. Wherever the allocation of this cell is equal to the value assigned to that cell number, s3 d5 allocation is equal to the positive the value you will get is, so 50 minus 100 minus 100. The cell value is 50 minus 100 minus 100. So after calculating you will get 150. In that loop, wherever negative sign is there, you have to take that values and add at the positive locations. So take 100 and add to the 50, and take 100 add to the empty cell. So then again check the opportunity cost values. If the opportunity cost values are all positive values, then multiply the number of allocations to the cost, that is the total transportation cost. So that's about transportation. So gate question, how, what type of questions they asked is, Question number 11. Question number 11, page number 105. GATE 2008. For the standard transportation linear programming with m resources and n destinations and total supply is equal to the total demand, an optimal solution with smaller number of non-zero values is desired. The best upper bound for this number is. So optimal solution, optimal allocations is when the demand is equal to supply, and as well as when the number of destinations, the supply equal to the standard with the source and destinations, and the supply is equal to demand, and optimal solution is reached. So optimal allocation is equal to m plus n minus 1. So that's answer. Next, another question is, very less questions they have asked in transportation. 34th question. The supply at three sources we have 50, 40, 60. Demand how much? 20, 30, 10, 50. Total supply is 150. Total demand is 110. So demand is less. He is asking, options are: a dummy of source of capacity 40 units is needed, a dummy of destination of capacity of 40 units is. So a dummy of destination of capacity of 40 units is added. Answer is B. Because supply is not equal to demand, supply is not equal to demand. So to equate it, we need to add into the demand say.